All right, in this video we are talking about solving equations using inverse operations, particularly one-step equations in this video. Firstly, I want to point out that when we are solving equations with inverse operations, we need to think about what the regular order of operations is. So, when we talk about order of operations, as we discussed in a previous video, we have our grouping, our exponents, multiplication, division, addition, and subtraction. Okay, so when we are solving equations, we're going to use inverse operations. This is our order of operations. Okay, so our inverse operations is the opposite operation. For example, if I have addition, my opposite operation would be subtraction. If I have multiplication, my opposite operation is division, and vice versa, right? If I have subtraction, my opposite is addition. If I have division, my opposite is multiplication, okay? In 8th grade, you'll talk about the opposite of your exponent rules, as well as what to do when you have grouping symbols involved in your equations, all right? So our order of operations is going to be a little bit different as well. Our order of operations when we are solving equations is going to be, instead of GEMDAS, we have SA for subtraction then addition. Those are kind of together. Then we have D and M. So we have our division and multiplication. Okay? And then we have our exponents and our grouping, which are last. Okay? So SADMEG is our order of operations when we are dealing with inverse operations for solving equations, okay? So those are inverse order of operations. One example is negative 3x equals 27. So I like to start myself off by organizing my equation. This isn't necessarily going to be helpful in this particular step, but when we get to two-step equations and multi-step equations in upcoming lessons and school years, this is going to be helpful. So what I'm going to do is I'm going to draw a line through my equal sign. I like to call it draw a wall, right? I'm going to separate my two sides so that way when I do the one thing to my equation, I remember to do it to the other side of the equation. When I only have one step happening, it's not too difficult to see the two different sides. But when I say one side of the equation, it means one side of the equal sign versus the other side of the equal sign, okay? Now I look and see what my operation is to start. Now this one's a little tricky because there's a negative 3 and x with a negative 3 with my variable, right? But this is not a subtraction problem. If you look, the minus is in front of the 3. There's nothing between 3 and x. This is actually a multiplication problem. When I have a number directly up against a variable, that makes it multiplication. Number against variable is multiplication. So make sure you jot that down somewhere. So I'm going to think about my inverse operations. Well, the opposite operation of times negative 3 is going to be divided by negative 3. Now, if I do something to an equation, if I do it to one side, I have to do it to the other. The reason for that is because an equation, equal, right? It's equal on both sides. If I change one side of it, it's not going to stay equal unless I change it in the same way on the other side. So I'm going to divide both sides by negative 3. And negative 3 divided by negative 3, the negatives cancel each other out. The 3's cancel each other out, and I'm left with just x, which is what I'm going for, right? My goal with solving an equation is to isolate the variable. The goal is to isolate the variable, okay? Now, negative 27 divided by negative 3, negative divided by negative becomes positive. 27 divided by 3 gives me 9, and that should be my final answer. Now I'm going to check my work here real quick. I'm going to say negative 3 times 9 should equal negative 27, and it does, which means that this is a correct answer. My next example is 1/7 x equals negative 3. Now, this does look like a multiplication problem, right? Because 1/7 is up against x, there's no sign in between it. However, I want you to think about the fact that this is actually more of a division problem. The reason for that is I can write this as 1/7 times x over 1, right? And I could get x over 7 is equal to -3, okay? Both of these equations are exactly the same. I didn't make any changes to the actual value of this equation. So fractions, remember, fractions are another way of saying division, okay? So the opposite of division, dividing by 7, is multiplying. So I'm going to multiply times 7, so that way I can cancel those out. But again, if I do it to one side, I do it to the other. So I'm going to multiply both sides times 7. This works up here too. I can do times 7 and then times 7, and that would cancel that out as well, okay? X is left alone, and -3 times +7 gives me a -21. I can check my work. 21 divided by 7 equals -3, and that is correct. Sorry, -21 divided by 7. I was going to say something that's not right there. This is correct. Next, I have a minus 12 equals -5. I'm going to draw my wall, keep my sides separated. Now, in this situation, I am subtracting from a. The issue here is I need to get rid of minus 12. So I need to think about what is the opposite of a minus problem, and that is addition. So everyone notice that how -12 and +12 should cancel out to give me 0? If you don't get 0 when you do that, then something went wrong, okay? Always double check that. Over here I have -5. Remember, if I do something to one side, I have to do the same thing to the other. Now I have opposite signs here, so I subtract. Okay, even though I'm writing addition, I'm going to do the operation of subtraction. And 12 minus 5 is equal to 7. 12 is larger and it is positive, so it will stay positive. A is alone, so A is equal to 7. I'm going to double check my work here. 7 minus 12 equals -5, and that would be correct because 12 minus 7 gives me 5, and we're taking away 12, which means it's negative. One more example here. I'm going to draw my wall. C plus 18 is equal to -2. I'm going to take away 18 from both sides. Now, even though I'm taking away 18, this cancels out here, right? The opposites mean that they cancel out and get a 0. But over here, I have two negatives, so I'm going to add those together, and I end up with -20. And -20 plus 18 does, in fact, equal -2, so that is a correct answer. All right, last but not least, I have two practice problems on here. 8x equals -16, and -4 plus r equals 8. Please go try those on your own. Pause the video, write them down, and check your answer with Mrs. Jackson before moving on. Good luck. Have fun.